Good morning, students. This is Dr. Priyanka, and I will be discussing sampling methods with you. In last video, we discussed what sample is and how is it different from population. And we even discussed how a sample is to be decided. And steps, if we talk about steps of sampling, then first of all, it was deciding target population. Then after that, it was about deciding a frame, sampling frame. And then we will be deciding which kind of sampling method we are going to use. And this is actually the third step we are going to discuss today, that what is a sampling design and how these methods are different from from each other, and how these should be applied in different situations so as to get the more accurate results as per the population. So let us start by major sampling methods. We have two major sampling methods. One is probability sampling and another one is known probability sampling. Probability, as the name suggests, it is known as known zero probability for every element. If each and every element in the population has equal probability to be selected. For example, you have got 1,000 people as your population, and you need to select 100 people out of that particular population, then as your sample. So what you will be doing, you will be randomly selecting 100 people out of that 1,000, and these 100 people would be having equal probability of getting selected as the sample of that particular study. That this is called probability sampling. But when we choose them deliberately, we choose one sample over the other just because of our convenience, or maybe some judgment we apply, in that we will be using some things which we call as known probability sampling. It is a probability of selecting any particular member is unknown, because when you try to put some judgment while deciding the sample, it is going to be your known probability sampling. Let us discuss them one by one. Let us discuss probability sampling. These are all the methods, all the bifurcations of probability sampling methods and non-probability sampling methods. Probability sampling method would be divided in four parts: simple random sampling, systematic random sampling, stratified random sampling, and cluster sampling. We will be discussing them one by one with examples. And non-probability sampling methods can also be divided in four parts. One is convenience sampling, then judgmental or purposive sampling, snowball sampling, and quota sampling. Let us start with probability sampling. Probability sampling means that every member of the population has a chance of being selected. They have the equal chance of being selected. We consider that there would be no biasness while selecting the sample. It is mainly used in quantitative research. More or less quantitative research would go for probability sampling methods. Then if you want to produce results that are representative of the whole population, then probability sampling techniques are the most valid choice, because you are trying to choose a sample. You are trying to choose a sample of people who might represent the whole population. So this is the best method, and this is also bifurcated in 4-5 methods. We will discuss them now one by one. One is simple random sampling, then systematic sampling, then stratified sampling, clustered sampling, and multi-stage area sampling. Let us start with simple random sampling. Sampling procedure that ensures that each element in the population will have an equal chance of being included in the sample. It is just randomly selected sample. One way of obtaining a random sample is to give each individual in a population a number and then use a table of random numbers to decide which individual to include, right? So this, you are just randomly selecting people. For example, if you want to select a random sample of 100 people, 100 employees from XYZ company, which is having 1,000 employees, what you can do is you can either generate random numbers of 100 out of the numbering from 1 to 1,000 through Excel sheets, Or you can do one more thing. You can include chits of, you can take chits of 1,000 people. You can take 1,000 chits with, and each chit would be having one name, and you can select the people through that chit method also, right? You will be selecting 100 chits from that ball, and you can get it done. For example, in an organization of 500 employees, if the HR team decides on conducting team building activities, it is highly likely that they would prefer picking chits out of a ball. In this case, each of the 500 employees has an equal opportunity of being selected. There is no bias in that, because you are putting one chit each person, and you will be selecting just 100 chits just like that. Its advantage is the most straightforward method of probability sampling, and it is the easiest method. But disadvantages are, you may not select enough individuals with your characteristic of interest, especially if that characteristic is uncommon. Sometimes there might be some people in the whole population which are different from others, and we might end up choosing none of them. So that might create some bias, but this happens. This is just by chance. This can happen or this cannot happen. This depends. And it may also be difficult to define a complete sampling frame and inconvenient to contact them, especially if different forms of contact are required. For example, email, phone, post, and your sample units are scattered over a wide geographical area. Yes, in such cases, random sampling is not suggested. Then systematic sampling. Researchers use systematic sampling method to choose the sample members of a population at regular intervals. It requires the selection of a starting point for the sample and sample size that can be repeated at regular intervals. For example, every nth name from the list will be drawn. Let us see how would we do it. For example, if you need a sample size n from a population of size x, you should select every x divided by nth individual for the sample. For example, you have 1,000 people in total. That means x is equal to 1,000, and you want to choose 100 people from them. Then select every 1,000 divided by 100 is equal to 10th. That means every 10th member of the sampling frame. This is again the easiest one, and this is considered as better method than random sampling method. Advantages: it is a very simple process, and predefined range is there, and hence this sampling technique is the least time consuming. You can actually when we discussed in at the time of random sampling method, we included 1,000 chits, and we were supposed to take out 100 chits, right? It was little more time consuming than deciding it systematically. Like, you can choose every 10th employee of the company from those 1,000 people. However, it may also lead to a bias. For example, yes, if a group of students were being sampled to gain their opinions on college facilities, but central list of all students was arranged such that the sex of students alternated between male and female. Choosing an even interval, example, every 20th student would result in a sample of all males or all females. Yes, it happens. Suppose there are total 1,000 students, and number 1 would be for male, number 2 would be for female, number 3 would be for male, and number 4 would be for female. If it is like this, then every 20th would be a female. So you will be actually taking the sample of either males or females if you decide it this way. So that can happen sometimes, and when we know that such a setting is there, then we can avoid using this particular sampling method. Then stratified sampling. In this method, the population is first divided into subgroups. We call these subgroups as strata, who all share a similar characteristic. For example, there are 1,000 people. We will be dividing this in 10 groups, 100 people each, and these 100 people would be similar to each other but would be different to another 100. each stratum is more or less equal on some characteristic, maybe for on the basis of income, or maybe on the basis of age, or maybe on the basis of some other attributes, or maybe their attitude level, right? So we will be dividing them on on the basis of some characteristic. The strata differ from one another, but each is homogeneous within itself. People who have been divided in different stratas are different outside the group. For example, if let us take a very small example, if you divide 1,000 people in supposedly in 4 groups, maybe on the basis of age you can decide, you can divide them in a manner like group 1 consists of people having age from 21 to 30. Then group 2 would be having age group of 31 to 40. Then group 3 would be having having people of age group 41 to 50. And then group 4 would be having people of age group 51 to 60. This way, all the groups would be homogeneous within and heterogeneous outside the group. Subsamples are drawn within different strata. Now you can choose people from each strata equally, so as to get equal age distribution throughout the sample. The units are selected at random from each of these strata after deciding the stratas. It is used when we might reasonably expect the measurement of interest to vary between the different subgroups, and we want to ensure representation from all the subgroups. We know that with age our opinions differ, so there might be a study which is dependent on how your opinion differ with age. So that can also be done through this. For example, in a study of stroke outcomes, we may stratify the population by sex to ensure equal representation of men and women. Yes, that can also be done. You can divide the whole population in male and female and then choose equal numbers from both the stratas. It may also be appropriate to choose non-equal sample size from each stratum. Yes, this also happens in some cases when stratas are of different sizes. For example, in a study of health outcomes of nursing staff in a country, if there are 3 hospitals which each with different numbers of nursing staff, hospital A has 500 nurses, hospital B has 1000 nurses, and hospital C has 2000 nurses, then it would be appropriate to choose the sample numbers from each hospital proportionally. For example, you can choose 10 people from hospital A, 20 from hospital B, and 40 from hospital C. This way it is proportionalized. This ensures a more realistic and accurate estimation of the health outcomes of nurses across the country, whereas simple random sampling would overrepresent nurses from hospitals A and B. Yes, it would actually do, because you might be choosing 10 from each hospital, then it would overrepresent hospital A and underrepresent hospital C. Do not, and yes, most important is do not confuse this particular sampling with quota sampling. We will discuss quota sampling when we will be discussing known probability sampling techniques. Cluster sampling. The purpose of cluster sampling is to sample economically while retaining the characteristics of a probability sample. Let's see how. The primary sampling unit is no longer the individual element in the population. You actually divide the whole population in different parts, or you can say you take one sample randomly from the population, and then you will be choosing that particular sample as the whole of your sample. The primary sampling unit is a larger cluster of elements located in proximity to one another. It involves dividing the population into subgroups. You have divided the whole population in subgroups, but each subgroup should have similar characteristics to the whole sample. For example, you divide 1,000 people in 10 subgroups, then all 10 subgroups must be having people of all age groups, must be having people of all income groups, so that if we pick one cluster out of that, that cluster contains all age groups, all income group people, right? We, in case of stratified sampling, what we did was we divided the whole population in different stratas of same characteristic, but now different stratas of different characteristics outside the group, but within the group everyone was same. But here we will be including all characteristic people in one group. We will be dividing people in 10 groups, and each group would contain, for example, 10 people of age from age group of 21 to 30. Each group would contain 10 people from that. Each group would contain at least one manager, one clerk, one supervisor, like that. So each group, each strata, you can say, each cluster of samples would be able to represent the whole population as a whole. So each strata of 100 people is equally qualified as a sample of the whole population now. Cluster sampling is a method where the researchers divide the entire population into sections or cluster that actually represent the whole population. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. For example, a company has offices in 10 cities across the country, all with roughly the same number of employees in similar roles. You don't have the capacity to travel to every office to collect the data. So you use random sampling to select 3 offices, and these are your clusters, and this method of sampling is called cluster sampling method. Disadvantages: this method is good for dealing with large and dispersed populations, but there is more risk of error in the sample as there could be substantial differences between the clusters. Yes, it happens most of the times, and it's difficult to guarantee that the sampled clusters are really representative of the whole population. There are some examples. For a cluster may be something like a village or a school in a state. So you decide all the schools in Hisar are clusters. You want 20 schools selected. You can use simple or systematic random sampling to select the schools. Then every school selected becomes a cluster. Now, if your interest is to interview teachers on their opinion for some new program which has been introduced, then all the teachers in a cluster must be interviewed. Though every economical cluster sampling is very susceptible to sampling bias, like for the above case, you are likely to get similar response from teachers in one school due to the fact that they interact with one another. But still, you can go with the sampling in case of cluster as well. Some observations for probability sampling methods. Simple random sampling is the most appropriate when the entire population from which the sample is taken as homogeneous. Systematic sampling is often used, more convenient than simple random sampling, and it is easy to administer. Stratified sampling techniques are generally followed when the population is heterogeneous and where it is possible to divide it into certain homogeneous subpopulations, which are called strata. And cluster sampling is typically used when the researchers cannot get a complete list of the members of a population they wish to study, but can get a complete list of groups or clusters of the population. That's all. We can have a diagrammatic view of probability sampling methods. For example, simple random sampling method, you can choose people's randomly from the whole population. Then systematic random sampling, like we can see every third person, every third, fourth person we are trying to choose. Like this, we can choose every third person, then every third, or every second person can be chosen from the whole population. It depends on the sample to be selected out of the whole population. Then stratified sampling, you will be making different stratas which are homogeneous within the group but heterogeneous outside the group. And then you can choose proportionate people from all these stratas. Then cluster samples, you will be making different clusters which would comprise of all kind of people in every cluster, and then you can choose one cluster as your sample. This is all about probability sampling methods. Now let us have a look at known probability sampling methods. In a known probability sample, individuals are selected based on some non-random criteria, and not every individual has a chance of being introduced. This type of sample is easier and cheaper to access, but it has a higher risk of sampling bias. It generally has. Inferences you can make about the population are weaker than the probability samples, and your conclusions may be more limited. If you use a known probability sample, you should still aim to make it as representative of the population as possible. It is divided in 4 parts: convenient sampling, purposive sampling, snowball sampling, and quota sampling. Convenient sampling is also called haphazard or accidental sampling. The sampling procedure of obtaining the people or units that are most conveniently available. For example, I know 4 people in a company and I might just end up interviewing those four people. That's it. And then there comes social desirability bias as well. So many biases are there at that time, and the people I might know are of same opinion as mine. So this is just not exactly done for a research study. This might be done just to explore your knowledge. Convenience sample simply includes the individuals who happen to be most accessible to the researchers. I know that these people would reply me, and so I'll just go and ask them their opinion about something, and I will leave other people, right? That would actually create the bias. This is an easy and most inexpensive way to gather initial data, but there is no way to tell if the sample is representative of the population, so it can't produce generalizable results. So it is better if you go with convenience sampling at the time of pilot study. You can go with this because this is costing you almost nothing, but at the time of actual study you should go with some other sampling. For example, you are researching opinions about student support services in your university. So after each of your classes, you ask your fellow students to complete a survey on the topic. This is a convenient way to gather data, but as you only surveyed students taking the same class as you at the same level, the sample is not representative of all students at your university. It is actually 100% biased sample. This way, people who are approachable to me would be sampled, and people who are not in my class or maybe who are not approachable to me are not in this sample. So and these people, these 5 people might be of my kind, might be having the same attitude as I have, right? Or at least these 5 people have similar attitude to themselves, right? And I have left these people who had different attitude than these people. That is why there was a group, right? So this is how we should not go with convenient sampling for all the research studies. This is best at the time of pilot study. Judgmental sampling. It is also called purposive sampling. An experienced individual selects the sample based on his or her judgment about some appropriate characteristics required of the sample member. It involves the researcher using their expertise to select a sample that is most useful to the purposes of the research. For example, I know that in a class 10, these 2 students are very intelligent. They would be able to answer everything I want to know about things going on in the school. So they might be knowing everything related to study, but they might not know things related to sports. So this would be a biased sampling once again. It is often used in qualitative research where the researcher wants to gain detailed knowledge about a specific phenomena rather than make statistical inferences, or where the population is very small and specific. For example, in case of knowing everything about school, I can pick different people from the class. I can pick one student who is intelligent, who is good in studies, to know about studies. I can pick one people who is good in sports to know about sports. I can pick one people who I know that have lunch every day in the canteen to know about canteen, right? So I might choose different people to answer different set of questions, and then I might collaborate that for my own knowledge, then apply it to the whole population while conducting actual research study. Sampling is done purely on proximity and not representativeness. It cannot be a representative of the whole population at all. This non-probability sample method is used when there are time and cost limitations in collecting feedback. Yes, example, startups and NGOs usually conduct convenience sampling at a mall to distribute leaflets of upcoming events or promotion of a course. They do that by standing at the mall entrance and giving out pamphlets randomly, right? So people who have not visited the mall would not be a part of that particular upcoming event. So that is a kind of bias we'll be facing in this sampling. This way, purposive sampling. I know this person will reply in a better way. I will ask him this set of questions I have. I will choose persons as per my judgment. Snowball sampling. Initial respondents are selected by probability methods. Additional respondents are obtained from information provided by the initial respondents. This technique is used in the situation where population is completely unknown and rare. Therefore, we will take the help from first element which we select for the population and ask him to recommend other elements who will fit the description of the sample needed. This way, this would create a chain of people, similar people. So this referral technique goes on increasing the size of population like a snowball. It helps in situations where we do not have the access to sufficient people with the characteristics we are seeking. It starts with finding people to study. For example, you are researching experiences of homelessness in your city. Since there is no list of all homeless people in the city, probability sampling is not possible. You meet one person who agrees to participate in the research and he puts you in contact with other homeless people that he knows in the area. The same in the case of HIV/AIDS, because people do not generally disclose about their illness to normal people who do not have any such disease. Though there is no normal people in the world today. This is how snowball sampling works. I will contact this person. This will tell me about other 3-4 people, and I have contacted one more person. He will also tell me about other people who have the same attributes in them. Then these people might also tell me about 3-4 other people. This way, chain of population will increase. This is one of the best methods in which we do not actually know people having similar attributes which we want to research. Quota sampling. Quota sampling is a method of sampling widely used in opinion, poll surveys, and market research. And it should not be confused with strata sampling. In strata sampling, we were actually making different stratas, and we were choosing people from each strata randomly. And in quota sampling is like defining some quotas and then randomly choosing people from them. Like this, the quota sampling starts with the idea that a sample should be well spread geographically over the population and that it should contain the same fraction of individuals having certain characteristics and as does the population. In this technique, the population is divided into number of stratas whose weights are obtained from a recent census or a large scale survey. Interviewers are then assigned quotas for the number of interviews to be taken from each stratum. For example, an interviewer might be told to go out and select 20 adult men and 20 adult women, 10 teenage girls and 10 teenage boys. So they could interview them about their television viewing. Like this is actually quota sampling. The interviewer is free to choose his sample provided the quota requirements are fulfilled. The main difference between quota sampling and stratified sample is that in quota sampling, the selection of the sample within strata is not strictly random. You can choose people who are more approachable. So it includes a portion of known probability sampling as well. The interviewer may omit certain section of individuals or may discard certain of the area entirely according to his inconvenience. And quota sampling suffers from the drawback that sample is not a random sample. This is how we go for quota sampling. Male above 50, we will be choosing male above 50 from this particular sample. Let us discuss some self-assessment questions. Name and describe the types of known probability sampling. You have to list down all 4 known probability sampling techniques and describe them. In which type of sampling does every element in the population have known zero probability of selection? This is very popular technique and it is simple random sampling. Name and describe the types of probability sampling. You have to list down all 4 probability sampling techniques and define them properly. Next is when a researcher uses students to participate in a study because he has easy access to them, what type of sampling procedure does this represent? When a researcher uses students to participate in a study because he has easy access to them, that means they are accessible. So it is kind of convenience sampling. When a local television station sends a crew to interview joggers in the city park on a beautiful spring day, this represents what type of sample? This is a kind of cluster sampling. When researcher instructs field interviewers to interview 25 workers in manufacturing industries, 25 in service industry, 25 in non-profit organizations, and 25 in healthcare industries, and 25 in government sector. This represents what type of sampling procedure? We just discussed it in the last, and it is quota sampling. That's all. We will discuss what is the appropriate sample design in our next video. We will just have a quick revision of all the sampling techniques, and then we will be discussing the appropriate sampling design. Thank you.